Hey, let's solve these exercises together. Please don't just watch these solutions, but please solve it on your own and then watch these solutions together. Let's start with the first problem. We want to retrieve 20, right? And how can I access to 20? There are going to be three numbers we need to specify. And I told you that the first number indicates the direction in the vertical direction. So vertically, the first elements are this one, the second elements are these one, and the third elements are these ones. And 20 is in this position. So the first position is going to be 1. Because in fact, the counting starts from 0. 0th, first, and second. And in these 2D array, we need to specify these two numbers. And in these 2D array, these ones are the 0th elements. These ones are the first elements, third elements, the second elements, and the third elements. And 20 is in the 0th elements, so it's going to be 0. So we have reached this array, subarray, and we need to choose 20, and it's at third position, 0, 1, 2, 3. So 3 should go here. So it will return 20. However, you can put just -1 here as well. And there could be many other ways to implement this. So if your answer or if your solution works, then that's perfectly okay. Don't worry if your answer is different from what I have here. And let's think about the second exercise. We want to retrieve 9, 10, 11, 12. Where are they? They are here. And as I told you, these boxes are 0th in respect of the first index. So we're going to put 0 here. And what should be the second index? It should be, we want to choose the third row in this 2D array, and it's going to be 2. And we are selecting all these elements in the 0, 2th position, and we can put colon here. Or simply you can just put 0, 2. It will give you the same answer. Okay. And let's move on to the third exercise. We want to choose all these elements. And what should you do? We're going to put 2 here. And because we are choosing all these elements, we're put colon here. And this could be simply a bracket 2, or this might be confusing, but you can put comma and ... here. So these 3 dots are equivalent to this expression. Okay, let's move on to the fourth problem. We want to choose 5, 6, 21, 22. 5, 6, 21, 22, 37, 38. Then what should you do? As you can see here, 5, 6, 21, 22, 37, and 38. In this direction, we need to cover all these elements. So we are put column here. And because in respect of the second axis, we are not covering all these directions, but only these two elements. So they are 0, first, second, third. And we are choosing the first element. So here we are going to put 1 here. And among these 5, 6, 7, 8, 21, 22, 23, 24, 37, 8, 9, 40, we're choosing the first two elements. So we're going to put 2 here, like this. And it will get you 5, 6, 21, 22, and 37, 38. Okay, let's move on to the fifth question. It might be somewhat difficult at the first glance, and you need to understand some Python functionalities to solve this problem. In this case, we want to get 36. Let's remove some problems here. Okay, we want to get 36, 35. So they are in the opposite direction. Rather than 35, 36, we want to get 36, 35. And 40 and 39, 44 and 43, 48 and 47. How can you solve this problem? Let's first get to these 4 elements. Then, in respect of the first axis, we need to go to the second element. So first, second, and 0th, first, and second. And in respect of the second dimension, what should you do? You're choosing all 4 directions. So in the second position, we need to put column. And what about choosing these 2 elements in the opposite direction? We're going to put 1 here. Then we can choose 2 elements. And when we want to do this from the back, we're going to put another column here and pass -1. Then it will say it means you're getting 2 elements, but from the back. Okay. So this is Python list functionality. However, you can use this functionality for NumPy arrays. Okay, so this one might be somewhat confusing at the first glance, but if you take some time, you will definitely understand this. If you are not able to solve 5th and 6th exercises, I solved the 5th exercise with you, and stop this video if that is the case, and try to solve 6th problem on your own using this functionality, and then resume this video. Okay. Okay, let's solve the 6th practice together. Here, we want to retrieve 1, 5, 13, 9, 5, 1. So these elements in 29, 25, 21, 17, and 45, 41, 37, 33. So in respect of the first dimension, we need to choose everything because we are covering all this area. And in respect of the second dimension, we're also choosing everything. However, we're getting elements from the back, like this. And we are not covering all these elements in this direction, but only this one. So we are going to put 0 here. Okay. So that was our first PPP exercise. From now on, we're going to talk about NumPy array math and universal functions. Let's say you want to change the values of a list. I am using this example quite a lot in this class. So let's say you want to increment each element by 1. So the result you want to get is 2, 3, 4, 5, 6, 7. And how can you do that? There are multiple ways to do this, but the most naive way is using 2 for loops. So you're going to enumerate this example list. What you are going to do is, for row index and column index, we're going to add 1. When we print example list, each component gets incremented by 1. However, this one looks tedious. It doesn't look efficient. And you can do something different. How can you do that? You can use Python list comprehension. Like this. So list comprehension reduces these 4 expressions, 2 for loop expression, into single line expression like this. However, still, this one looks tedious, and sometimes you could make some mistakes writing this expression. Then what we're going to do is when you want to add 1 to each element, then you can use something called universal functions. You can add 1 to each element using this np.add function. And this function is called universal function because you can expand this scalar number to the shape of another input array. However, as I showed you in the previous section, you can just simply plus 1 like this. And both are okay. And the thing is, if you run this expression, what NumPy does is it automatically changes this expression to this one and then perform this expression. So both are okay, this or this. However, in general, I never seen this expression people using, but programmers usually use this expression. And you can do various things using these universal functions, like you can power each element like this, and you can do the same thing. This is power operation for Python. You can do the same thing like this. And there are various universal functions like square root this. So if you need to do some operations, then don't try to implement those operations using list comprehension or for loops, but search online or have a look at the official document of NumPy, and there definitely will be the expressions or functionalities you are seeking. Okay, another thing I want to introduce here is reduce functionality. So this one add numbers in this array in the direction of axis 1. So this is similar to sum operation. You can also pass axis 0, like this, and it will return 5, 6, 7. And I'll show you some picture. And you can do the same thing using this sum operation. They're going to produce the same result. And I'll visualize this operation. So if you pass axis 0, then it will add numbers in the direction of axis 0, which is vertical direction. So these numbers are summed in this direction, and 5, 6, 9 will be returned. And if you pass axis 1, this direction will what this sum will consider. And if you run this operation without specifying the axis, then it will simply sum all the numbers in this array. And there are many functionalities NumPy provides, like npmin, npstd, npvariance, npmin, npmax, many functionalities. So if you want to do something, then as I told you, don't try to implement it on your own, but have a look at the official document, and there definitely will be one functionality that you are seeking for. And if that's not the case, then you should implement it on your own, of course. However, that will seldom occur. Okay, and from now on, we're going to talk about broadcasting. So what is broadcasting? I told you that when you run this operation, NumPy will automatically change this expression to this one and perform this universal function operation. And you can view that as broadcasting. Broadcasting is not simply, so this one is broadcasting. So if you add np array 1, 2, 3 plus 1, then NumPy will automatically change this one as this vector having the same shape as this one and add these two vectors. So that's what actually Python is doing, NumPy is doing. However, you can do something different for 2D arrays. Let's say we have an array having 2 dimensions. Like this. And let's say each array, example array 1D, this shape. And can you add this EG-array 2D plus EG-array 1D? Even though they have different shapes, you can add these two numbers. How is it possible? The thing is, when you try to add a 2D array with 1D array, then Python adds another row to this 1D array and makes this array into 2D array, having the same shape as the other 2D array. And then you can add these two arrays like this. So that's what happened under the hood. And this one might look very convenient. However, sometimes you need to be very careful about this because sometimes you didn't intend this operation. However, Python implicitly performs broadcasting, and that might not be what you want. So you need to understand that, oh, NumPy does not throw errors, even though these two arrays do not have the same shape, because it performs broadcasting. So keep this in mind. From now on, we are going to talk about advanced indexing. Here, specifically, I'm going to discuss memory views and copies. This topic is also very important, and it can cause quite a lot of error. And if you don't know this concept, you might have difficulty in debugging your code. Okay, let me start with an example. Here, our 1, 2, 3, 4, 5, 6 array is coming again. And we learned that we can access to the first row using this command. And when we print out first row this way, then it returns as expected 1, 2, 3. And if we want to increase the values of the first row, then it's going to be like 99, 100, and 101. And here, I would like to show you what will happen to EG array. This is unexpected. The first row of EG array also changed from 1 to 3 to 99, 100, and 101. This is because if you just access to some parts of an array using this indexing, then this first row is not actually created. It's just another memory view of this memory space. So you are not actually creating a new array, but it is connected to this one. And we call this concept a memory view. In other words, when you are slicing or indexing some arrays, you're creating new memory views. However, you are not actually creating new arrays. And I'm going to show you another example. Let's use our example once again. We can access to a part of these elements. And let's see what happens to our array. Then these values changed. Okay. And another thing we can do, let's define this EG-array again. And the center column can be expressed in this way. This is actually not center column. If you add 99 to this memory view, then the original array gets changed like this. Therefore, when you always slice some arrays, keep in mind that you're creating new views. And what if you don't want to create new memory views, but rather new arrays? In that case, you can use something different approach. If you use this copy method, then EG array and first row are separated. So even though you change something to the first row, nothing happens to our EG array, the original array. So if you want to create a new array using this content, then you can just use this copy method. And when you're making a big program, then you sometimes forget that you created new views. In that case, what you can do is you can use shares memory method to check whether these two arrays share memories or not. It will print out first. However, if I just remove this copy method, then it will say they actually share memory. So they're actually from the same space, memory space. However, you need to keep in mind that if you just use this universal function method, then they are going to be separate arrays. So you just need to keep in mind that slicing creates memory views. However, these universal function methods or operations will create new arrays. Okay? Okay, so from now on, I would like to give you a PPP exercise. Don't run this code block. However, just try to guess what the results will be. So you just need to figure out what the results will be on your own. And after that, please move on to the next video. Please do this on your own.